All right, so again, we're going to do an algebraic method for solving a system of linear equations. And this is called substitution. And so instead of graphing and finding the points, or finding the point where the two lines cross, we're going to do this algebraically. So they have the process written down here. There's 5 steps. We got one blank we got to fill in. But to me, it looks like they messed this up. The expression, the word expression should actually go in that blank. So we're going to cross this out. And it should say resulting expression. Okay, so the process is step 1, solve one of the equations for one of the variables. Step 2, substitute the resulting expression into the other equation. Step 3 is solve for the variable. Step 4 is plug that solution into one of the original equations and solve for the other variable. Step 5 is write your solution as an ordered pair. So the ordered pair would represent the point where the two lines cross. So let's do example 1. So example 1. Now, is one of the equations solved for one of the variables? You got 2 equations here, right? We need one of them to be solved for one of the variables. Is it? That means get x or y by itself on one side of the equal sign. Do we have that? Ava says yes. Yeah, we do. Yeah, we have, in fact, we have the top equation is solved for y and the bottom equation is solved for y. So we know now that y is equal to 3x. Well, that means y is the same thing as 3x. So I can take this 3x right here and I can substitute it in for y in the second equation. So step 1 was already done. And then that's step 2 right there is to plug 3x in for y in the second equation. And when you're plugging it in, well, that's called substituting. That's why this is the substitution method. So now that second equation would now look like 3x equals x minus 2. All right, so step 3 is we got to solve for the variable. So how do we solve that for x? Nabe? What's that?
Add 2.
Oh, you could, but I think I want to get the x's on the same side first. So Tom said subtract x.
Yeah.
All right, so subtract x on both sides. Then those will cancel out and make 0. So 3x take away x would be 2x. So now we have 2x on the left side. On the right side, all we have is negative 2. Don't forget to bring that sign down, that subtraction in front of the 2. And then to finish, we just divide both sides by 2. These cancel out on the left-hand side, and we get x equals negative 2 divided by 2. Actually, I'm going to leave a little room here. Negative 2 divided by 2 is negative 1. So there's half of your solution right there. You got the x coordinate. Now you got to find the y coordinate. Well, you can take that x equals negative 1 and plug it into either one of the original equations. So let's, I don't know, let's put it in, take x equals negative 1 and knock it off, guys. Take x equals negative 1 and let's plug it into this x right here. You could plug it in the top one. You could do 3 times negative 1 if you want to. You get the same answer either way. So then that one would become y is equal to negative 1 and then minus 2. All right, that negative 1 doesn't really need to be in parentheses. I just put them there so you could see what I was plugging in or what I was substituting. So let me, I'll take those parentheses out of there. So it'd just be -1 minus 2. So what's -1 take away 2 more? Yep, -3. So that's the second part of your solution. That's the y